everyone, we're going to find the solution of the differential equation that satisfies the initial condition y of pi divided by 3 equals a. So the first thing we're going to do is just kind of rewrite this a little bit to help solve. We're going to group our x's and y's. Let's write this y prime as a derivative of y with respect to x. And then we're going to have equals a plus y. And I'm going to cross multiply and move this down here. So this is going to be tan of x. All right. Also, I can rewrite this as distribute this dx up here and cross multiply. So I can write this as dy. I move this down here because it has the y in it. A is just a constant. Equals, I'm going to go ahead and write this as cotan of x dx. So that's just our arrangements. Now, since a plus y is in the denominator, our a plus y may not equal 0. So that's just our restrictions there. Now, let's integrate both sides of the equation. So we're going to have the integral of dy divided by a plus y equals the integral, and I'll go ahead and write this as cosine of x divided by sine of x dx. So for our left-hand side, we're going to get ln of absolute value of a plus y. And for the right-hand side, if we let u equal sine of x, then du equals cosine of x dx. So using u substitution, we're going to get the integral of 1 divided by u du. So this is going to equal ln of absolute value of a plus y equals, this is going to be ln of u plus c, and our u is sine of x. So I'm going to go ahead and substitute that in. So sine of x. All right. Now that we have that, we're going to go ahead and solve for our y. And to solve for y, we're going to go ahead and power this up with e and convert this to exponential. So we're going to get absolute value of a plus y equals, and right now I'm just going to write this as e to the power of ln of sine, absolute value of sine of x plus c. Of course, I can bring this down as well, but what I want to do is, before I move on, rewrite this. This can be written as e to the power of ln of absolute value of sine of x times e to the power of c, using your properties of exponents. All right. Therefore, I can let k, and we can also write this as plus or minus, but we'll do that in a minute. I'm going to let k equal this part right here. So let's do that. We're going to get absolute value of a plus y equals e to the power of c times e to the power of ln of absolute value of sine of x. All right. Now this part right here is just going to be absolute value of sine of x. So we're going to let I'm going to take away the absolute value sign, and I can do that if I let k equal plus or minus e to the power of c, because absolute value includes the negative. So I'm going to do that and write this as k, and then I can take away the absolute value sine of x. So I have sine of x. All right. So now that we have that, we can solve for everything. K was non-zero. but we can restore the excluded case by letting y equals negative a, and that would let k be 0. So now let's do our initial condition. We have y of pi divided by 3 equals a. So substituting that in, we're going to get a plus a equals k times sine of pi divided by 3. All right, so this is going to be 2a equals k, and sine of pi divided by 3 is square root of 3 divided by 2. So solving for k, we're going to get k equals 4a divided by square root of 3. So now let's write all this out. Now that we have our k, let's see if I can still squeeze it in here. Now that we have our k, I'm just going to substitute this back into my k. So I'm going to get a plus y equals k, which is 4a divided by square root of 3 sine of x. And I still think I can squeeze it in. So solving for y, you just subtract the a. So basically your y equals 4a divided by square root of 3 sine of x, and we're going to subtract this a. And this is your final answer. Thank you. Have a nice day. Bye-bye.